The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, good evening, everyone. I'm Rob Meyer. I run outbound product management here at GridGain. We're going to start in just a moment, but first I want to make sure that everybody can hear me. So if you can, please raise your hand. There's a little hand icon at the upper right-hand screen. Just want to see a couple go up. I see James. Good, I see a few people raising their hands. Perfect. Please let us know throughout the webinar if you're having issues. You can raise your hand. You can also ask questions. There's a questions little tab in the right-hand side. And I will be answering some when I'm not speaking throughout the session. But please let us know. And we've got other people watching as well. We're going to take some questions at the end. You're going to be on mute during the webinar. If you do have any questions, please just type them in there. I'm going to save the hardest for last for Alexey. And so with that, let me introduce the speakers. You may know me from previous webinars. I ran outbound product management here. Alexey Kukushkin is one of our lead professional services folks. He works with a lot of companies, helping them with their GridGain deployments. In addition, he has also worked on Kafka over the years and contributed to what you see today as the GridGain Kafka connector that we got certified with Confluent. So today, the webinar is all about getting started with Ignite, with Kafka, and with GridGain and Confluent, whatever combination you're using to build out streaming applications. So what we thought we'd do, if you go to the next slide, Alexey, what we thought we'd do is first kick it off by talking about the why. Why are we even interested in this kind of integration and in streaming applications? And then I'm going to turn it over to Alexey, who's going to go into the details of how the connector works, how you do the deployment, monitoring, and management, and then walk through some good integration examples that you'll actually be able to use later to help you get started. But first, let's talk about the why. So if you skip ahead to the next slide. Hopefully most of you know Apache Kafka and you've heard of Confluent. You probably do, or you probably wouldn't be listening. But just for some of the other folks, Kafka is it's a streaming, a high scale streaming or messaging platform. Like most of its predecessors and peers, if you've been working with messaging and streaming before, like we have, you build streaming applications on top of a messaging backbone like this as a combination of producers or publishers and subscribers or consumers. The messaging platforms have historically provided some pretty good fault tolerance mechanisms, ways of persisting queues or topics, different levels of guaranteed delivery, and Kafka has all of that. It's learned from its predecessors really well, and it's very much a proven platform. It's written in Scala as well, which is a great language. And there are thousands of companies using Kafka today. Confluent, like GridGain, is the commercial entity that provides the commercially supported version, whether it's on-premise or now you can get it in Marketplace and put it in various clouds as well. They have additional connectors, additional language support, security, deployment, monitoring, and management tools for the business critical deployments, and they provide the global support and services. This is a lot like Ignite and GridGain. If you go to the next slide. Ignite is one of the top 5 Apache projects. Kafka's up there as well. It is an in-memory computing platform, meaning it's in-memory computing technology that gets used across many different types of projects for adding speed and scale to existing apps as an in-memory data grid. It is used to store data at pretty massive scale as a distributed in-memory database with persistence. It's kind of like a in-memory real-time version of HDFS with SQL and ACID transactions. It's also used a lot for streaming analytics, and it's starting to be used for machine and deep learning as well. The reason is in-memory computing it's one of the technologies that needs to be used if you're really going to build real-time applications that either do real-time analytics or automate decisions. And that means it's going to be used with technologies like Kafka, which is also about real-time analytics and decision automation. So what makes this so popular is that, like Confluent, GridGain, just so you know, GridGain is the commercially supported version of Ignite. Like Confluent, it provides the global support and services. It also we donated the original code to the Ignite project. We continue to be a leading contributor. And beyond adding the global support and services like Confluent, we add additional connectors like the Kafka connector that we're going to talk about, and the security deployment monitoring management. So if you go back to the next slide, it turns out that in order to be a distributed platform, whether you're talking about Kafka or you're talking about Ignite, you need to have the messaging and the event infrastructure built in. So we actually do a lot of similar things to what Kafka does under the covers. We have messaging, we have a namespace. We do a lot of event-based processing like Spark, but that's not the point. The point is you need to be architected like this to participate in large-scale event-driven or streaming applications. And so if you go to the next slide, the point is that many companies use these technologies together, and you can call it KISS. You can call it Kafka, Ignite, Spark, and SQL, as a combination of technologies that get used together for delivering these kinds of apps. Kafka is usually used as the backbone, as a messaging backbone for piecing together the different nodes that are the engine, some combination of Ignite or GridGain with something like Spark, which together do the processing really well. So at any point, these nodes could be GridGain or anything else, and the subscribers or the consumers could be GridGain or anything else. It's typically what you see. So there are several examples up there publicly. So on the next slide, I thought I'd give one, which is ING Bank. They've done several GridGain Kafka applications, and that's helped them get to market faster than some of their competitors. There have been various regulatory requirements that are pushing banks towards being much more of a real-time Amazon or PayPal kind of experience. And they were one of the first to release a SEPA exchange. SEPA is basically micropayments that allows anybody in Europe to pay a bill or get a salary in any other currency, or not really currency anymore because they're all euros, but from any other country without having to have a bank in that other country. It basically moves money around for pennies instead of the $15 wires transfers that used to be Europeans' reality. So this is something that's a global standard. Every bank that participates in the European Union had to have it. And ING was one of the first. They run millions of transactions a day through a combination of Kafka and GridGain. So with that, I thought if you want to hear about this one, you can go to imcssummit.org. You can search for ING or David Fallen, who gave the presentation, and you'll find the one in Europe. You may find some other ING presentations as well. They also talk a little bit about Kafka. So go there and see some of these examples. There are plenty of good examples up on the IMCS Summit.org site where a lot of good practitioners are presenting. But with that, I thought I'd turn it over to Alexey so we can dive into the details of how this connector works and how you do the deployment, the monitoring, management, and all the examples. So Alexey, I pass it over to you.
Thank you, Rob, very much for explaining us why we need Kafka integration. Even though we are a sophisticated platform, we still might need Kafka integration. Yeah, thank you for this introduction. In the next section, let's learn Ignite and GridGain Kafka connector features and actually how Ignite and GridGain connector compare against each other. First, let's talk why we need to develop a so-called connector. when we already have very well-defined Kafka consumer API and Kafka producer API. They are very easy. They are designed using very well-known publish-subscribe pattern that I think every senior engineer knows how to use. But yeah, you can do your integration using consumer and producer APIs. But if you do that, you need to solve problems, lots of problems. And here on this slide, I listed some biggest problems which you will face. For example, if you want to integrate numerous applications, for example, you have a system, a complex system where you have MongoDB, where you have Cassandra, where you have GridGain, where you have some relational databases and much more. You have to learn each system because you need to understand how to get data from it and how to put data into it. And you, in addition actually to learning Kafka, right, you have to learn each system. So this is a huge investment in development. Then you need to take care about making sure that your system understands data from other systems, right? And if you want to do that, you will have to introduce some sort of schema, some sort of metadata that describes each piece of your data. Then you need to do some tedious work, very tedious work, very many lines of code, converting data from each format to your format, to the format of your system, because you have many systems that communicate through Kafka. Then you need to think about scalability, because just imagine you develop some producer, right? But a simple producer will be just one JVM, just one instance. But we are talking about big data. We are talking about distributed systems. So if you have high traffic coming from distributed system, your producer or your consumer will definitely become a bottleneck. So you need to think how to scale your producer to consumer data flow. And then you need to think about how to recover from failure. Because imagine that your producer fails, right? And during the downtime, when your producer actually is down, or your consumer is down, right? You have some data updates in the source system, right? And you don't want to lose that data. So this is another issue, and you actually will encounter much more issues. But this is just one of the biggest ones that require lots of implementation and lots of time to architecture this. So Kafka connector, it's an answer. It's an answer to all those challenges. Kafka connector, it's a plugin. It's already out-of-the-box integration that already addresses all those challenges using best practices. It doesn't need well-developed connector is very highly configurable. It doesn't need any coding at all, even for the most complex integration scenarios. Connectors are usually developed by vendors. So we are talking now about GridGain, GridGain connectors. For example, GridGain connector was developed by GridGain community, or GridGain company. Ignite connector was developed by Apache Ignite community with help from Confluent. So we at GridGain and we at Apache Ignite community definitely know our systems, right? So we know how to apply best practices. We know the most efficient way to get data from our GridGain or Ignite and to put data into Ignite. And we worked with Confluent to ensure that we use best practices, best Kafka practices as well. So you can be sure that when you have a connector, you have it is implemented using best practices and it doesn't require any coding at all. Talking about GridGain connector. So GridGain connector is based on Connect API, like other connectors. It's a framework which already encourages design for scalability, which already allows you to support failover, and it allows you to support data schema. I mean, you don't have it by default, but it provides you the framework to get all those features. Just for information, GridGain source connector uses Ignite continuous queries, and GridGain sync connector uses Ignite data streamers. This is the best API to get data from Ignite and to put data into Ignite. So in this picture, you can see that instead of having some custom producer and consumer that you would have lots of time and resources to spend on developing, right? Instead of that, on the producer side, you have some ready-to-use Kafka source connector, and on the consumer side, you have some ready-to-use Kafka sync connector. On this slide, just wanted to address some confusion about deployment. So in this ecosystem, Kafka Connect ecosystem, you have 4 distinct clusters. for types of servers, if you want. You have some source system. In our case, this is some source GridGain system. You have Kafka cluster. In Kafka cluster, just to introduce some terminology, in Kafka cluster, nodes are called brokers. So we are going to use broker later to address Kafka nodes. You have a separate Kafka Connect cluster. In Kafka Connect cluster, nodes are called workers. We are going to use worker to address Kafka Connect node later in the slide. And you have some destination cluster. So my point is that you don't need to deploy like all the nodes on one server, like Kafka broker, Kafka Connect worker, and Ignite node, just everything on one server. You can do that, but on the contrary, I recommend separating, like running each instance of each type on its own node. So better allocate less node to each instance, but provide all the node resources to that instance. That will be more manageable, more efficient. And for example, speaking about Ignite and GridGain, when it starts, it assumes that it is the only component, only node which is running on the server. It calculates, by default, it calculates resources, assuming that this is the only node running on the server. So yeah, I suggest that if you deploy this ecosystem, you have 4 different clusters. Now let's talk about features, GridGain connector features. So you have 2 independent connectors. By independent, I mean they are managed independently. That means they can be configured independently, started independently, stopped independently. You can use one connector or the other. You don't need to always use them together. You have source connector, which streams data from GridGain into Kafka and uses Ignite continuous queries for that. And you have GridGain sync connector, which streams data from Kafka into GridGain, and it uses data streamers for that. Now let's just briefly review Kafka Connect architecture, how we achieve scalability. So in Kafka Connect ecosystem, we have tasks. Tasks, they do all this work. They load data from source system, they process data, and they process and transform data, and they just push transform data into Kafka. Then we have connectors, this connector entity. Connector is something which actually splits work, or splits incoming work into partitions, and assigns those partitions to tasks. So yeah, partition. Partition is actually how the work is split. It depends on the connector. So what is partition depends on the connector. We will review it. And each partition consists of records. A record is a key value timestamp. So each record has 3 attributes: key value and timestamp. So scalability, it is achieved by splitting work into multiple partitions, assigning 1 or more partitions to tasks, running 1 or more tasks on workers, and running 1 or more worker on each physical host. This is just normal situation, right? In every distributed system, you have a similar picture. So now let's talk about what is partition. For example, we have, there is a sample connector provided with Confluent platform, file system connector. In that connector, partition is a file. So they process multiple files and they consider each file as a partition. For example, we have another connector, JDBC connector, that we are going to use today. In JDBC connector, partition is either a table or a SQL query. So it has 2 options, either to read data by tables or read data by SQL queries. So each separate query or table, it's a separate partition. Now, in GridGain, partition is a cache. So we actually split work by caches, and correspondingly, records are cache entries. So now let's talk about failover, in another very important architectural requirement. But let's introduce some terminology. I think it should be familiar to those who are familiar with distributed systems, but anyway, it's very important to understand this. What is rebalancing? Rebalancing in the context of Kafka Connect. So in Kafka Connect, rebalancing is a reassignment of Kafka connectors and tasks to workers. When it happens when a new worker joins or leaves the cluster. For example, you decided to scale your cluster in or out, right? You add more workers and you need to rebalance. You need to reassign. So when you add a new worker, you need to reassign your caches, your partitions, to more workers. But for example, what if another partition is added or removed? We are talking about GridGain or Ignite. In our case, it's a cache, right? You dynamically created a new cache, and you got more work for your connector. In this case, we need to rebalance again. We need to start more tasks, or if you already reached the limit, we have to assign a new cache to some existing task. Failover. So failover, it's a correct resuming operation correctly after failure. So what means correctly? How do we resume after failure or rebalancing without losing cache updates which occurred when our Kafka worker node was down? So that's the question, how we do correct failover. Now let's talk about source offsets. Again, it's those terms are used in every system. I'm now talking about Kafka Connect ecosystem. In Kafka Connect ecosystem, source offset is a position in the source stream. So for example, file system connector. So source offset, it means line number. For file system connector, source offset is a line number. For JDBC connector, source offset is JDBC connector supports only tables which have incremental ID. And in that case, offset is basically is a value of the incremental ID column, right, for JDBC connector. These source offsets are Kafka Connect. It provides infrastructure to actually store those source offsets. So Kafka Connect has persistent and distributed reliable storage, offset storage, that you can use to save your offsets. But you don't need to do that manually. When you actually commit data into Kafka using Kafka Connect API, Kafka Connect will automatically save committed offset in that storage. And when you start your worker, when you start your work, you actually look up that storage, you get the last offset from that storage, and then you can resume your work from that offset. This is how Kafka Connect infrastructure allows you to basically to correctly failover without losing any data. Now, let's consider a GridGain connector. The problem is caches, they don't have any offsets, right? As I said, tables, they usually have incremental ID, but caches, even though we can design caches with some incremental fields, it's not often the case. We cannot limit our connector with caches which have some incremental field, right? So caches in general, they don't have offsets. That's the issue. How we address that issue? We need to compromise. We have created multiple policies, multiple failover policies. Each policy has its own advantages and disadvantages. So the default policy is none. Basically, we don't do any offsets. By default, we don't save any offsets. We don't have any offsets. So when our connector starts, it just starts listening to current data. Whatever data they were during downtime, they are lost. That's a drawback. The advantage of this policy is that it is fastest. It's just the fastest approach. Another policy is called full snapshot. Again, we don't have any source offsets if you pick this policy, if you configure this policy. We always pull data from the cache upon startup. What it achieves? It gives us. Actually, it solves the issue, right? You don't lose any data because every time you start, you pull all the data. So that means any updates that happened during the downtime, you will catch those updates. But the problem is that first of all, it is slow. If you have a big cache, it's simply not applicable. You simply cannot use it for really big caches because you always be getting like the entire cache. And another thing is it violates exactly once data delivery guarantee because you get duplicate data. But the advantage is that we don't lose any data. So we have some universal policy that can be used with any caches. We called it backlog policy. In this case, we support offsets. We actually create offsets for caches. What happens if you configure backlog policy for your source connector? In this case, when source connector starts, it starts so-called Kafka backlog service. It's a microservice. It's an Ignite service. This service creates so-called Kafka backlog cache. Key in this cache is a numeric offset. It will be auto-incremented. And the value in this cache, it has two fields. it has a cache name, and it has cache entry, serialized cache entry for that cache. Then it runs continuous queries, and those continuous queries monitor target caches, and they actually just duplicate all the data into that Kafka backlog. And the connector, it actually normally, I mean, with other policies like none and full snapshot policies, normally continuous queries, they are running inside the connector, and they just push data into Kafka right from the continuous query listeners. But in this policy, continuous queries are running inside GridGain cluster. And Kafka connector, it simply queries Kafka backlog. This Kafka backlog, it has offset, so we always query data starting from the last offset. Kafka Connect infrastructure allows us to commit the last offset, so we always run SQL query, just get all the data from Kafka backlog starting from the last offset. So this is how we achieved universal solution. But the problem with this solution, it is, first of all, it is intrusive because you create some stuff inside your cluster. Maybe you won't be happy with that. And another thing, you need to plan capacity. It has actually complex configuration because you need to estimate how much memory you need to allocate for this backlog. I will talk about capacity planning for Kafka backlog in the next section. We will have another section where we talk about this. Okay, we have another feature in our GridGain connector. It's dynamic reconfiguration. I already mentioned that, but just to reiterate, this connector, it monitors all your caches that you have in the system. If a new cache is created or maybe a cache is removed, it automatically reconfigures itself. You can monitor all the caches, like all the caches in your system, or you can configure whitelist or blacklist or both. To actually define subset of caches that you want to monitor in the source system. This is called dynamic reconfiguration. We have another feature, it's called initial data load. You can specify a Boolean property, shall load initial data. If you say true, I want initial data, then when your connector starts, it will first load original data that you already have in the cache before the connector started, and then it will start listening for new data. Sync connector. Everything which I said before, it was about source connector. And for sync connector, I don't have to say that because our sync connector, like actually any other sync connectors, they already support scalability and failover thanks to Kafka, because we read data from Kafka, and Kafka is already streaming system supporting all these concerns, all these architectural concerns. Kafka has some internal offsets. They are not visible to us, but it has them. So you always know that you are getting data from the last offset. Kafka connector, sync connectors, they are scalable because they just read data from topic, and that happens in a distributed mode. You can have many connectors attached to the same topic, and they will be just getting the data in a distributed mode. You don't have to implement anything for that. It's just inherited from Kafka Connect infrastructure. And sync connectors inherently support failover because Kafka, it auto commits offsets for the pushed data. So Kafka, it takes care about this. Data schema. Our GridGain connector, it supports data schema. And this is the data schema. It's actually what makes GridGain connector understands data from other connectors, right? And this is what makes other connectors or other consumers understand data that our connector emits into Kafka. Source connector, it attaches Kafka schema, which is built from Ignite binary objects. And sync connector converts Kafka records into Ignite binary objects using Kafka schema. There are some limitations to this. For example, annotations are not supported. So if you use some annotations, like for example, affinity key mapped, or SQL, annotate fields for SQL, it will not be transmitted. It's possible to implement this, but currently it's not supported. So you have to configure this manually on the receiver side if you want these features available. Some types are not mapped. For example, Kafka, it doesn't have Ignite char. it will be converted to Kafka short type. So it will be lost basically. Ignite char will be lost. Same thing, Ignite UUID, unique ID and class, they will be lost. They will be converted to string just because Kafka doesn't have this analogs in Kafka type system. Other than that, everything is supported. Like Ignite, Kafka also supports arrays of any type. So we convert arrays very well. Ignite connector features. So we spoke about GridGain connector, which is part of the GridGain offering. But Ignite, it also has, Apache Ignite, Apache Ignite, open source Apache Ignite. It also has Ignite. It also has Kafka connector. Ignite source connector, it pushes data from Ignite into Kafka, and it is built on Ignite events. And this is actually very bad. So to use this connector, you must enable at least put event. But if you want to support removals, you also want to enable remove event. The problem is enabling this event, it actually significantly decreases cluster performance, and this is bad. This is very negative impact. Anyway, this is you must do this because it is based on Ignite events. And sync connector is also based on data streamers like GridGain connector. Now let's compare GridGain features and Ignite features. So this is like a sort of summary, and also it explains Ignite connector features because we already reviewed GridGain features in details. And now let me just indicate which features are supported in open source Ignite and which are not. Scalability. Scalability is limited in Ignite source connector. So Ignite source connector is not scalable at all. It supports just single cache. In the configuration, you specify a cache, and it starts one task to process that cache. So it's basically not scalable. It does make sense to start a cluster of Ignite connectors because there is always just one connector. You can create multiple instances with different configurations if you want to process multiple caches. But single connector, it's not scalable. Sync connectors is scalable as well. Failover. Open source Apache Ignite connector doesn't support failover at all. So it starts listen to events, and that's it. So whatever happened during downtime, it will not pick it up. Preserving source data schema, basically data schema. Ignite connector, it doesn't support data schema at all. It simply converts everything into Ignite binary format, and that's it. So on the receiving side, you have to write some code to actually parse Ignite binary format. GridGain connector, it supports schema, so everything happens automatically. Handling multiple caches. Yeah, it's not supported. Ignite source connector doesn't support it. GridGain connector supports any number of caches. Dynamic reconfiguration. Again, it's not applicable to Ignite source connector because it supports only one cache, and GridGain connector does dynamic reconfiguration. Initial data load is not supported by open source connector, but supported by GridGain connector. Data removals, both connectors can handle data removals. Serialization and deserialization, both connectors. Kafka Connect, it already provides you two serializers, string serializer and JSON serializer. They are less efficient than if you use Ignite binary serializer because it is native. Both connectors, they have Ignite binary serializer. So in the configuration, you can always specify Ignite binary serializer. Filtering. You can actually filter data on the source side using Apache Ignite connector, but Apache Ignite open source sync connector doesn't support filtering. GridGain connector supports filtering on both sides, on the source and sync sides. Transformations. You don't need to implement transformations in connector because Kafka already has a feature of single message transformations that allow you to do all the transformations you want. So you can do transformations using Kafka SMTs. DevOps, open source Ignite connector just does some free text login. GridGain connector has health model. We will review it later. Support, open source Apache Ignite connector basically is supported using with Apache Ignite community, and GridGain connector is supported by GridGain, and it is certified by Confluent. Packaging. UberJar in one case, connector package in another case. Deployment, we will review deployment, just a little bit, very similar deployment. We will review it in details later. Kafka API version, Apache Ignite connector is built using Kafka 0.10, And the GridGain connector is built using the latest 2.0 Kafka. For today, this is the latest Kafka. So source API is Ignite events for open source, continuous queries for GridGain, and Sync API is data streamers for both. Now I think you understand how Ignite connector compares to GridGain connector. Now let's talk about deployment, monitoring, and management. GridGain connector deployment, it basically consists of 3 steps. Prepare connector package, register connector with Kafka, register connector with GridGain. Why you need to register connector with GridGain? Because of that backlog policy, because there is some stuff which is running inside GridGain. This is why you have to basically register connector with GridGain. That's why. Step 1, prepare connector package. GridGain connector, it's part of GridGain Enterprise or Ultimate, starting from release 8.5.3. This release will be released in the end of October 2018, very soon. So with that release, you will be having our Kafka connector, part of that package. The connector will be in this directory. So when you unzip that package, unpack that package, you will see the connector in this integration GridGain Kafka Connect directory. Just to reduce size of the package, we removed some duplicate dependencies. So before using this package, you have to run script copy dependencies just to pull our missing GridGain and Ignite dependencies into Kafka connector package. So you have to do these 3 steps to make your package consistent. Register connector with Kafka. This is universal approach for any connector, and what you have to do, you have to basically put this connector either on a network share or just distribute it onto each Kafka Connect worker node. And then you need to update Kafka Connect worker configuration on every node. You have to specify path to your connector package in the plugin.path property, like I specified here. Okay, assuming that you use GridGain version 8.5.3 to register GridGain connector with GridGain, you just need to put these 3 jars onto GridGain class path. Or just create, you can put it in the libs directory, or you can create user subdirectory inside libs and put these 3 jars into there. That's it. This is how you install GridGain connector. Ignite connector deployment is very similar, but you don't need the step number 3 because there is nothing on the Ignite side in this connector. So that means you don't need to register it with GridGain. You only need to prepare a package, and you need to register it with Kafka. To prepare the package, there is no actually package built, so you have to manually copy jars from the Ignite Kafka module in the Apache Ignite distribution. You have to grab these jars, and you have to copy them in some directory. And then you have to put that directory on each Kafka node, and again, update plugin path or Kafka Connect worker plugin path to point to that package. Monitoring. So for monitoring, we have this document on the GridGain side. I'm talking about GridGain connector monitoring, where we have very consistent health model. What is health model? Health model, it provides a list of everything that can happen to the connector. And each event, it has some unique ID, which uniquely identifies that problem. It has severity. Error means the system is not operational. Warning means the system is degraded, has degraded health. Info is just info. You have description, and what is important for each event, you have action. You can create automated recovery script using the action description. So what you can do, these events, they are logged into Apache Ignite log. You will see entries like this in the Apache Ignite log. You can set up your monitoring system. Any monitoring system, it supports parsing logs. So you can set up your system to parse for specific events and do recovery action as specified in the health model. Ignite Ignite connector, it doesn't have any health model defined. So my advice is just general, right? You run negative tests, you examine negative tests. I mean, you simulate different kinds of failures that can happen in your system. You check output, Ignite output and Kafka output, and then you train your monitoring system for specific pattern. Now let's review an example. It's a very simple example. It's definitely not like what Rob described before. It's very simple, but actually it just shows you step by step what you need to do some simple integration. So what we are going to do, we are going to review this scenario: how to propagate relational database updates into GridGain. Ignite and GridGain, they have third-party persistence, also known as cache store. What it allows you, third-party persistence, it allows propagating cache changes into external storage like RDBMS, and also it allows you to if you read data from the cache and the data is missing in the cache, the data will be automatically retrieved from GridGain or Ignite cache. Oh, sorry, from underlying database table. But I often see this question on the Apache Ignite user list. People ask, can we just update cache asynchronously from the table? So, for example, when the change happens, at the moment the change happens in the relational database, that change has to be propagated into Ignite cache. Cache store cannot do that. Cache store cannot do that. But you can do this using this simple Kafka integration that we are going to review right now. So right now we are going to do this. Whenever relational table is updated in the relational database, the change will be instantly propagated into GridGain cache. In this exercise, for simplicity, we run everything on the same host. That's definitely not a real situation, but this is just for simplicity. We are going to use GridGain 8.5.3. And you should have GridGain home variable set on all the nodes. And we are going to use Kafka 2.0, and you have to set Kafka home to point to the Kafka installation. So this is what we already have. Step one, we are going to run a database server. We are going to use H2 database server because it is very simple. It's already part of GridGain. So you download H2 server and you set H2 home environment variable and you run it. So you run your server using this command and it starts on these ports. It will automatically open H2 web console and you will specify this URL. So we are going to work in this directory. So for this exercise, our work directory is going to be TMP GridGain H2 connect. So you will specify this URL in the H2 web console and you press connect. So in the web console, you will create two tables. You will create quotes table, which will have some ID, date time, timestamp, and price. And you will create a trades table, which will have some ID, symbol, and that's it. And then you will insert one record into trades table and one record into quotes table. So yeah, this is what we have in the end of this exercise. When we select data from these tables, we have a record IBM in trades and we have some price in quotes. So now we have some relational database, two relational database tables running in H2 database. Next step, we are starting GridGain cluster. So we have very simple configuration, just discovery, local host discovery, single node discovery on the local host. That's it. We start Ignite like this, and it is successfully started. Next step, we are going to deploy source and sink connectors. So for source, we are going to read data from H2 database. It's a relational database, and for that we have Confluent JDBC connector that you can just download from Confluent site. It's free. You unzip that package, you copy that package into TMP, into this directory, and then you copy default Kafka Connect worker configuration file into that directory, and you modify plugin path to point to our connectors. Now we start Kafka cluster. It's also going to be just single broker, single node cluster. We create some very simple Zookeeper configuration file, just almost default one. Then we start Zookeeper. Zookeeper is required for Kafka. Then we start Kafka broker with this configuration. It's just single broker cluster, nothing special. So yes, our broker started, and basically this is the output you will see when it successfully starts. Next step, we configure our source connector, source JDBC connector. So connector configuration, it consists of generic properties which are applicable to any connector, and specific properties which are applicable to specific connector. So general properties are connector name, connector class. This is going to be JDBC source connector, and maximum number of tasks that you want to allow in the Kafka Connect tasks that you want to allow. So now there are specific properties. For JDBC connector, you specify JDBC connection string. You specify which tables you want to monitor. You want to monitor quotes and trades. JDBC connector, it supports only tables which have either timestamp, incremental timestamp, or incremental ID field. Our quotes table, it has incremental timestamp, and our trades table, it has incremental ID. So the mode of operation is timestamp plus incrementing. And the timestamp column name is datetime, and incrementing column name is ID. So the topic prefix is H2. That means it will get data from trades into Kafka topic H2 trades, and data from quotes into Kafka topic H2 quotes. Then you configure sync connector. This is GridGain sync connector. Again, you specify connector name, you specify maximum number of tasks, you specify connector class, you specify which topics you are interested in. You are interested in H2 quotes and H2 trades, and specific properties. Specific properties are configuration file. So we specify basically how to connect to that cluster. And we have topic prefix. Why we need this? Because we want to trim, we want to remove this H2 prefix and create caches which are called quotes and trades. So it will understand that the H2 is actually a prefix, and the cache name should be the topic name without prefix. Next step, we start Kafka Connect cluster. So this is a standard script, Kafka Connect standalone, because we just do single worker deployment. If you deploy it on multiple nodes, you will start Connect distributed. But the next parameters is our worker configuration file that we already configured before, and you just list any number of connectors. We have two connectors. We have H2 source connector properties, and we have sync connector properties. So you will see this output when the connector successfully starts. Both connectors start. So after they started, just open GridGain web console and see what we have. And you will see that before we had just empty cluster, but sync connector, it automatically created two caches for us, quotes and trades. Now, if you go to the queries page of the GridGain web console and do scan query for trades, you will see our entry. And if you do scan query against quotes, you will also see our entry. So that's it. We loaded initial data because by default, GridGain sync connector, it loads initial data. Now, we want to propagate some real-time data. And for that, having all that stuff running, we insert more data into our H2 tables. So we insert like Intel, and we insert some price for Intel. So this is what we now have in our H2. We have two entries. Let's go to web console, do scan query against quotes and trades, and we see that we instantly got the next entry here. So that was a very simple integration, which actually has some practical. I mean, you can use it in practice as well. Okay, now let's quickly go through some scalability tuning hints and tips. If you want to improve performance, then disable processing of updates on the sync connector side. So if you disable processing of updates, it will behave much faster. This is how data streamers work, because sync connector, it uses data streamers, and it will be much faster if you disable processing of updates. So you can do that using by setting shell process updates into false on the GridGain sync connector side. Dynamic schema. Actually, the schema by default, GridGain source connector, this is about source connector. By default, GridGain source connector thinks that your schema cannot change, because really, usually, in most cases, our caches, they have some fixed schema. So once you added some entry to the cache, you can be sure that other entries, other cache entries, they will have same schema. So this is why, by default, GridGain connector, it simply caches schema when it sees the entry for the first time, and then on the subsequent updates, it simply uses cached schema. That significantly increases performance. But if this is not the case, if you use your cache to put any type of data, you actually can use cache to put any kind of data into it. Our caches, they are not typed in general, right? If this is your case, then you have to enable dynamic schema, but do it only if you really need this. If you don't need dynamic schema, don't enable it. And actually, you can disable schema completely. For example, you can simply disable schema, and on the receiver side, you can just manually decode your messages. Or, for example, consider this scenario. You do data center replication using GridGain source and GridGain sync connector, right? In this case, you don't need schema at all, because both connectors are GridGain. They both understand each other. So in this case, you can just disable schema. Disabling schema gives you very, very significant performance boost. Carefully choose failover policy. So default failover policy is none. That means we will lose our data. But just ask this question: can you allow losing data? If yes, then use default policy none. If you cannot allow losing data, but your caches are small, for example, you have reference caches like list of states, list of countries, man or woman, right? In this case, you can use full snapshot policy. It actually will give you duplicate data, but we have just caches, right? We can leave you duplicate data as well. So for small caches, I think you can use full snapshot failover policy. But if you need both exactly once and at least once delivery guarantees, if you cannot allow losing data, then you need to use backlog policy. And if you need backlog policy, you need to very carefully plan capacity of that backlog cache. So backlog cache, it is created in the Kafka Connect memory region. You can customize this name using some configuration property, but by default, it is called Kafka Connect. And you need to estimate how much memory to allocate to that cache, because if you allocate, if you don't have enough memory, the data will be evicted if you don't have persistence enabled for this memory region. So to plan this, consider your worst case scenario. Think about maximum connector downtime in your system, because your system, it will have some specifications, the maximum downtime of any component, right? Next, consider what is your peak traffic, and multiply maximum downtime to your peak traffic. That will give you how much data you must feed into your backlog. This will give you a number, how much memory you have to allocate for your backlog. And that's it. So if you have any questions, let me know.
All right, so I think we have a few. I will start to go through them. Feel free to ask any questions in the question tab, and I will pass them on. So the first one was, actually, as someone was watching this, they were wondering, how would you add a new messaging connector, since you just built the one for Kafka or you worked on it? How would you recommend someone put in place a messaging connector for, let's say, a proprietary UDP messaging platform?
Thank you. That's a good question. Okay, my answer now is going to be just my personal experience. So just consider it as a just personal experience. So I would say this: develop connector only if you need out-of-the-box solution. I mean, only if your solution is going to be used by more than one scenario, in more than one scenario, in more than one installation. If you develop something proprietary just for your system, it's better to use producer API and consumer API, because it's just a real headache to debug connector. I mean, developing connector is more complex than developing integration using consumer and producer API. Because the API is more complex, because debugging and troubleshooting is more complex, and so on and so on. So I recommend you to start. So first, answer the question: are you a vendor? Actually, are you going to distribute your integration to others? If yes, then you need a connector because it's a ready-to-use plugin. If this is just for your system, for your internal system, like in some enterprise system, then start from producer and consumer API. It will be easier. I would say this. Does it answer your question?
Yeah,
okay, I hope yes. Yeah.
Is it the data streamer API that you'd be using, or is there another connector framework that you point them towards in the Ignite doc?
Oh, actually, maybe I misunderstood the question, because I thought the question is how you develop connectors for a different system, not GridGain, not Ignite, right? So I answered.
No, it'd be a connector for a new messaging, like a different product from Kafka. How would you develop that Ignite connector or GridGain connector? What's the connector framework within GridGain or Ignite? Okay,
I understand. Yeah, I understand. So that question, actually, I answered a little bit different question. But if the question is if you want to integrate Ignite or GridGain with some other offering from Confluent, Kafka, right? In this case, we already use best practices. I just recommend the same thing that we already using. Use continuous queries on the source side because they provide exactly once delivery guarantees, and they are very fast. And use data streamer on the sync side to inject data into Ignite or GridGain. This is the fastest solution that you currently have in Ignite.
Okay. On the second question is on the sync side. If you were doing a sync connector, not a source since the schema is coming from Ignite or GridGain, but when you're using a sync, does the GridGain connector, because the Ignite connector does not use schema, does the GridGain connector use the Confluent schema registry to understand records?
Oh yeah, it can. Yes, you can. Actually, I have Confluent schema registry configured for that connector. You actually don't need any development for that. It is just part of the Confluent infrastructure. In this presentation, actually, I did not mention Confluent infrastructure because they have lots of very nice tools. I mean, the Confluent team, they released lots of useful tools. For example, Confluent Hub. You can very easily, just using some command line utility, install all connectors. They have schema registry, right? You can use schema registry with GridGain connector perfectly. You can use Evra schemas with GridGain connectors as well.
Perfect.
Yeah, you can. Yeah.
Yeah, that was the exact question. So that's a yes. And then where are these examples going to be available? Are you going to post them anywhere, or?
You mean the example like what I just described?
Yeah, the one you went through in the slides.
Yeah, we already have documentation for GridGain connector, and you have two examples in this documentation. They're a bit different. So you have an example of doing Ignite data center replication, and you have an example of implementing cache store using GridGain connector. So there are two examples already available, and I think I will might publish this in a sort of other blog. I mean, this example, right? Yeah, we will think how to make it available to public somehow.
Yeah. So the short answer is you can go to the GridGain. If you search for GridGain Kafka, the GridGain doc comes up. It'll give you a lot of the details that Alexey went through in terms of the differences between the Ignite and GridGain connector, configuration, the error messages, and all that, including these examples. And then the example we just went through, we actually have to figure out how we're going to publish it.
Yep.
But we will figure out some way of getting it out there and let everybody know.
Yep.
All right. Well, those are all the questions we had. So at this point, Alexey, I want to thank you so much for going through the details and the message behind the messaging.